So now we want to talk about rational equations. And to talk about rational equations, I have to talk about what is a polynomial. Because a rational expression is the quotient of two polynomials. So we have to know what a polynomial is. It's not just anything, such that the degree of the polynomial in the denominator is greater than or equal to 1. And I'll explain what that means as well. A rational equation is an equation that contains one or more rational expressions. So these are rational expressions because they're polynomials over polynomials. So what is a polynomial? So a polynomial is always of the form x, but it could be y, it could be z, it could be anything. Okay, so the x is just a variable where a is a real number. So a real number is actually any number that is on the number line. So a is a real number. Any number is fine. A is called the coefficient. Okay. And we know that x is a variable. That's our variable. That could be any number, right? And n is an integer. So an integer is any whole number, positive or negative or zero. So basically, -2, -1, 0, 1, 2, 3, 4, and so on. It could be positive or negative, but there's no decimals, no fractions. It's a whole number, okay? So n is an integer, and it's got to be greater than or equal to 0. And we call that the degree. Okay. So what more should I tell you? Well, let's look at a couple of different expressions and see if they're polynomials. So let's say I have 3x, and I'm going to say coefficient, degree, and then is it a polynomial? So here our coefficient is 3. Our degree, so x is really the same as x to the first power. So our degree is 1 because n there is 1. Even though it's invisible, it still has a degree of 1. And does it fit our assumption about what a polynomial is? Well, a, which is 3, is a real number, so that works. X is a variable, and n is an integer, and it's greater than or equal to 0. It's actually greater than 0, so this is a polynomial. I can also say 3x squared plus 5. Now here I have two different coefficients, so I'd have to specify, but the degree is always going to be the highest valued n. So here my degree is 2. And now the problem is we have to figure out, is 5 in this form ax to the n? Well, there's no x, but there really is, because if I wrote x to the 0 here, anything to the 0 power is always equal to 1 as long as b is not equal to 0. So 0 to the 0 is not 1, but any base to the 0 power is always 1. So that's why this is usually not showing. But there is a degree on that. So that, let's see if it fits. So the coefficient is 5, and then we have our x to the 0 power, and 0, well, that's an integer, and it is greater than or equal to 0 because it's equal to 0. That makes this whole expression a polynomial. Okay, so this usually trips people up, that x to the 0. Like if I just have 5, my coefficient is 5 and my degree is 0, and this is still a polynomial. Okay, now what is not a polynomial? Well, the square root, 5 times the square root of x plus 2. I can see I have coefficients, but this is the same as 5 times x to the 1/2 power plus 2. And now my n is not an integer, it's now a fraction. Because of this, that makes this not a polynomial. This is equivalent to 5x to the 1/2 plus 2, and this is not a polynomial. But if I have the square root of 5 times x plus 2, that is a polynomial, because the square root of 5 is a real number and x is to the 1st power. So I would have my coefficient as the square root of 5, and my degree is again 1, and this is a polynomial. Okay, so I think that explains what a polynomial is. Now that we know what a polynomial is, then any rational expression is a polynomial. So a rational expression basically is a polynomial over a polynomial. So if I look at this, I look at 2 minus x, well, that's a polynomial. X plus 5, that's a polynomial. That means that is a rational expression. Same over here. 4 is a polynomial, and x plus 2 is a polynomial. So we have a polynomial over a polynomial, which means both of these are rational expressions. And because there's an equal sign, we can say this is a rational equation. Okay. So a rational equation is an equation. Remember, equations always have an equal sign that contain one or more rational expressions. So let's take a look at the next thing. A rational equation is an equation consisting of one or more rational expressions, with any other expressions of the equation being polynomials. So whenever I see a rational equation, it has to be, we know what a rational equation is, it's a polynomial over a polynomial. And if we want to solve, if we have an equation and we want to solve it, then the other pieces have to be polynomials. So let's see what that means. So determine which of the following equations are rational equations. So is A a rational equation? Well, yes, because I have a polynomial over a polynomial here. This is a polynomial plus a polynomial, and this is a polynomial. So I can say this is a rational equation. Now, B is not really a rational equation. because there's no denominator on this side, and this side here is not a rational equation. So neither side is a rational equation. This is a number, it's a polynomial, but it's a number, and this is a polynomial. So we have a polynomial equaling a polynomial, but neither one of them are rational. So this is not a rational equation. Okay. So now that we know what a rational equation is, what we want to do is solve for these rational equations. So how do I solve something like this? Well, the first thing I want to do, this will not always be given to you, but it is very important. So the value x equals -2 is a restricted value. Do you know why it's a restricted value? Well, we can say that if I put -2 into either one of these fractions, I will have 0 in the denominator. So I always have to look at my denominator, and I can see that x can't be -2 because if it was -2, we would have 0 in the denominator, and we can't ever divide by 0. Let's start solving this. We have 2 minus x over x plus 2 plus 3 is equal to 4 over x plus 2. Now remember, if you have a 3, it's the same as 3 over 1, right? So now what I'm trying to do, add or subtract fractions. I need a least common denominator, right? I need the denominator to be the same. So, well, I can see that x plus 2 is the same for both of the rational functions, but it's not for the 3 over 1. But 1 there is the denominator, and I can turn that 1 into x plus 2 by multiplying by x plus 2 over x plus 2. So I'm going to say here, my least common denominator is x plus 2. And remember what we did before. We're going to do the same thing here. We're going to multiply both sides by x plus 2. And then I'm going to distribute. So I'm going to have x plus 2 times, I'm going to try to do it so that you understand what I'm doing. You can skip a lot of these steps, but I'm going to keep them in there. So plus x plus 2 times 3 is equal to 4 over x plus 2 times x plus 2. Now, actually, the way I wrote this isn't very good. We need to put parentheses around that x plus, all these x plus 2s, because we're not just multiplying the 2 times that fraction, we're multiplying x plus 2 times the fraction. So make sure you put parentheses around that x plus 2, that LCD. Now, before I multiply, I'm going to simplify. So I can say x plus 2 over x plus 2 equals 1. So I get 2 minus x. And here I can distribute. So I get plus 3x plus 6 equals, and again, I can cancel this x plus 2 with this x plus 2, which leaves me 4. Now we have something that's a lot simpler to solve, right? So let's combine like terms. So we have 2x, 2 plus 6 plus 8 equals 4. I subtract 8 from both sides, and I get 2x, these cancel, equals -4. Divide both sides by 2, and I get x equals -2. Uh-oh, that's a little bit of a problem, right? Why is that a problem? Well, we started off by saying that x cannot be -2, right? If x is -2, that eliminates any possibility that is not a solution. So because I only have one solution, which is x equals -2, and I know x cannot be equal to -2, I'm going to say this has no solution. So an extraneous solution is a solution to an equation obtained through algebraic manipulation that is not a solution to the original equation. So an extraneous solution is what we had here. This x equals -2 is an extraneous solution because it's not a solution to the original equation. Okay, that ends 1.1. Thank you very much.